Welcome to this lectures on problem solving and programming in C course. This is the lecture 4, and the title of the lecture is flowcharts. In this lecture, we will see how to represent algorithms in a diagrammatic format. Flowcharts are basically diagrammatic representation or diagrammatic or pictorial representation of algorithms. So in this lecture, first let us try to understand what is algorithm. What is an algorithm? So algorithm is basically pictorial representation of an algorithm. Flowchart is basically pictorial representation of an algorithm. So a set of boxes to denote various computational tasks and arrows to show flow of execution of the steps. So there are some basic boxes or shapes are there to represent each form of computational task. One computational task can be input, output, or process, or condition checking. So for each of these computational tasks, we have a special symbol or special shape or a box. So using that box, we will represent that particular task, and then we will show the flow of execution with the help of arrows. Let us see some examples. So these are the flowchart symbols. So for input output, we use parallelogram shaped box, and for process, for example, of assignment or some computation statements you want to record, those statements will be shown as a rectangle. So some conditions, suppose if you have a if statement where there is a condition, also in repetitive statement there is a condition. So if the condition is true, you are going to execute some set of statements. If the condition is false, you are going to execute some other set of statements. So to denote the condition block, we use the rhombus symbol. And then flow of execution will be denoted by arrow symbol. Okay. And then start of the algorithm and end of the algorithm will be denoted by circle. An algorithm will have one start, exactly one start symbol, and then it may have a more than one stop places. More than one place, we can have a stop symbol, but all those will be exclusive. Only the execution will only reach to the exactly one stop symbol. So these are the examples we have seen in the last class. We have written algorithms for these 5 problems: sum of 2 numbers, maximum of 2 numbers, printing numbers from 1 to n, printing odd numbers up to n, printing mathematical tables. We have seen algorithms for these 5 problems. Now let us see how to write or develop flowcharts for these problems. Flowchart is also a pictorial representation of an algorithm. Sometimes a picture is more readable or more understandable than a text. So flowcharts are diagrammatic representation of algorithms. Sometimes they help us to understand the algorithms better and faster. So let us try to develop algorithms for these 5 problems one by one. The first problem is sum of 2 numbers. So this is the algorithm we have written in the last class. So input A, input B, C equal to A plus B, output C. It has 5 statements. Let us see how to create a flowchart for this problem, for this algorithm. So any algorithm, in the flowchart will have a start symbol. Start. This is the start, which will be represented by circle. And then there is a input A statement, right? Input A. Input A is basically we use for input and output, we use parallelogram. Parallelogram input A. And then followed by input B. Input B is another parallelogram. Input out statement we use parallelogram statements and boxes. Input B. And then there is a process statement which is C equal to A plus B, right? So we use rectangle for computation or process. This is a rectangle. P equal to A plus B. Okay. And then followed by output C. Output C, for output also we will use parallelogram. Output C. And then this is the last statement. We will stop. Circle, use a circle to stop. This is a flow chart for algorithm for addition of two numbers. Input A, there is a start of the algorithm, then input A, input B, C equal to A plus B, output C, and stop. So this is a simple algorithm which uses a plain sequence statements, input, output, and assignment. Okay, the arrow symbol shows the flow of execution. It means after once you start, this is a statement, first statement will be executed. After that, this statement will be executed. After that, this statement will be executed. So this arrow mark will tell you the flow of execution from the current statement, what is the next statement. Okay. Then our second problem, maximum of two numbers. Our second problem is maximum of two numbers. Let us see the algorithm for maximum of two numbers. This is the algorithm for maximum of two numbers. Input A, input B. If A greater than or equal to B, then output A. If else, output B. Now, this is our algorithm. Let us see how to develop a flowchart for this problem. We have a start symbol, start, and then we have input A, input A. Then you have input B, input B. And then we have a condition statement. For condition statement, we use a rhombus symbol. Okay. So it will have two paths. One is in this side, another in this side. This is for true, and this is for false. What is the condition? A greater than or equal to B. If A greater than B equal to, if A greater than B true, then the statements will be executed from this path. Otherwise, the statement will be executed from this path. So if A greater than B, what is the statement? So we should output A. Output A. Otherwise, if the A greater than B is false, then what we should do? We should output B. So, and then once these statements are done, so what you need to do? We should stop the algorithm. Stop. Okay. So whichever path you take, right? So all these paths. So whether you come this path or whether you take this path, eventually it will reach the stop state. So you have a start, then input A, input B. If A greater than B, if it is true, output A. If A greater than B, greater than or equal to B is false, then output B, and then you stop. This is the, see, at this box place, either you choose this path or this. We cannot choose both because they are only one of the condition is true. Whether A greater than B equal to either true or false. So when it is true, you take this path. Otherwise, you take this path. This is how a condition statement is represented in a flow chart using the symbol called rhombus symbol. Let us go through the next problem. So printing numbers from 1 to 10. So this is the algorithm which uses a for statement. The same algorithm we have written using while statement, do while statement also. So let us see how to represent this algorithm as a flowchart. We have a start symbol, start, and then you have input n, input n, and then we have this for I equal to 1 to n, do output I, and for this is your first statement. How do you see? How do you convert this to flowchart? For any first statement or while statement or do while statement has three blocks. One is basically initialization, and another one is condition, and then this statement inside the block, and then incrementation. Okay? So initial value of I is 1, I equal to 1, right? This is a process. So let us use a rectangular symbol to make I equal to 1. Immediately you should have a condition. So when is it going to enter this block? If I value is less than or equal to n only. So first thing we need to have a condition checked. So that's why you have a rhombus symbol. I less than or equal to n. So if it is true, true. If it is false, if it is true, what does it mean? You are going to enter this for loop. So the statement output I will be executed. So this is a parallelogram. Output I is executed. Output I, right? And then you should have a see this I value will be incremented from I equal to 1 to n, right? So I should be incremented. And this is a process statement. I equal to I plus 1. After this, so we again should go to this condition checking, this place. So once I value is printed, I incremented, we'll go for 2. If 2 less than n, then we'll execute this again. I becomes 3. If 3 less than n, execute like this. If I is greater than n, then what we need to do? We should stop the algorithm. Stop the algorithm. So this is how you achieve a repetition. A repetition statement is basically combination of process, process and rhombus symbol, condition symbol, and then arrow marks. So using process and condition and arrow marks, we can achieve the repetitive statement. So output I and I plus I equal to I plus 1. Same thing I can also write using the post increment. So do while loop also I can do like this. So basically I equal to 1, I equal to 1, output I, output I, output I, and then you have a condition, output I, and I equal to I plus 1, I equal to I plus 1, and then you have a condition, I less than or equal to n, true, false, false means you stop, if it is true means you will go here, here. So this is basically the entry control repetition. This is exit control repetition. This is while loop. This is for while and for. This is for while and for. Or for. And this is for do while. Do while is exit control, right? First we do the process and then we have a condition. So output I equal to I plus 1, I less than n. I less than equal to 2, then you will go here. Otherwise, you will stop. This is how you write, represent repetitive statements and condition statements in flowcharts. Let us go to the next problem. Next problem is printing odd numbers up to n. Printing odd numbers up to n. This is the problem. And then we have a input n. There it has also a input validation statement also. Ideally, for every algorithm, we should do input validation. And then you have these statements. Let us try to develop an algorithm for this, flowchart for this. Yes. So first thing is we will read start. Okay. Then you have input n. Input n. Then we have input validation. Input validation checking will come here. If n less than or equal to 0. If it is true, if it is false. If it is true, what you need to do? We should output a message. Output a message. Put invalid input. Invalid input. Output invalid input and then stop. And then stop. Okay. Otherwise, if it is false, n less than or equal to 0 false, it means n is greater than or equal to 1. Then we should go for the actual algorithm, actual algorithm. So what we need to do? We will initialize I equal to 1. I equal to 1. So you will have a condition. I less than or equal to n. True, false. If it is false, we will stop the algorithm. Stop the algorithm. If it is true, then what we do? We will output. Again, we will have another condition. What is that? If I division by 2 is I is odd or not? If I is odd. I percent 2 equal to 1. I percent 2 equal to 1 is odd. Is it odd or not? If I is a modulo symbol, percent is a modulo symbol. I percent 2 equal to 1. It means that it is odd number. True. If it is true, what we do? We will output I value. Sorry. Let me make it a bigger one. Output I. Okay. And then what we need to do? Here false. Whether it is false or right, false or not, we should then increment the I value. I equal to I plus 1. Then we should go to this condition again. Now, condition again here. I less than or equal to n. Okay. This is the flowchart to print odd numbers from 1 to n. So you see here, this has only exactly one start symbol, but it has two stop statements, but they're exclusive. So if the program reaches this place, it will reach only exactly one place. If the input is invalid, it will it will go here only. Okay, it will stop the algorithm. Otherwise, it will come here. And then eventually, I based on the I value. So every time you're checking whether I is odd or not. If it is I is odd, you're displaying the I value and incrementing I. Whether it's I is odd or not, we are incrementing I anyway, and then we are again going for checking the I less than equal to n condition. This is a flowchart for displaying odd numbers from 1 to n. Let us look at the other next problem. This is the last problem, printing mathematical tables from up to 10 tables up to 10 rows. So this is the algorithm. We have used a nested repetition. And then let us see how to draw a flowchart for this algorithm. You have a start symbol, start. There is no input. So we have first I is set to 1. I equal to 1. This is a process symbol. Then we have condition I less than equal to 10. If I less than equal to 10 is false, what does it mean? We have processed all the tables. So we can just stop the algorithm. Okay. Otherwise, if it is true, then what happens is we need to go for the j equal to 1, next for loop. J equal to 1. And again we should check if j less than equal to 10. J less than equal to 10. If it is false, less than 10 means false means we have operated all the j values. So we should go for the next iteration. Next iteration of I value. I equal to I plus 1. Then it goes from here to here. Okay, I value is incremented and we are going for the next iteration of I value. And then j is again set to 1, and j is, if j less than equal to 10 is true, then what we need to do? We should output output I into j is equal to I star j. Should output I equal to I star j. And then probably new line also. I'm not writing the new line here. You should also display new line here. I'm not writing that. And then what we need to do, we should increment the j value. J equal to j plus 1. And then go here. Again check for the next j value. Okay. So this is how, see, I should add one new line here, one new line here, and one new line here. I can add new lines here, new line, because after printing every row, we should move on to the new line. So you should have a new line symbol here, new line. New line symbol. So after this new line and then go here. After this new line and go here, output new line and go here. So this is how you can represent repetition inside repetition. So the control starts here, I is initialized. If I less than equal to 10 is false, we are going to stop the algorithm. Otherwise, you are going to initialize the j value as 1. See, for each I value, j value is coming from 1 to 10. So that is why we need to initialize j equal to 1. If j less than equal to 10 is false, it means that we have computed the one iteration of that inside for loop. I mean, complete iterations of the inside for loop. Then we need to go for the next iteration of I, right? So that is why I is incremented, and then you go to the condition again, I condition. Otherwise, if j less than equal to false means we need to print a row of the table. So that is why I output I into j equal to I star j. That is printed. Then j equal to j plus 1, and then you can add a new line here, and then you go to the another next j value, j greater than equal less than equal 10 is true. Again, you execute them. The j less than equal 10 is false. Then you go here and again go for the next iteration of I. This is how you can represent nested repetitions. Okay, this is also flowchart for printing mathematical tables up to 10 values. And this is the algorithm. And that's it. Thank you so much.